Welcome to Daily Papers, the podcast where we break down the most interesting new research papers into something you can actually understand.
Today, we're talking about a paper that could fundamentally change how we use and customize AI. Imagine being able to create a specialized AI assistant in seconds, not hours or days.
The paper is titled Drag and Drop LLMs, Zero-Shot Prompt to Weights. It sounds a bit technical, but the core idea is as simple and cool as its name suggests.
Right, so let's start with the basics. We hear about large language models, or LLMs, all the time. Think of things like GPT-4 or Llama. They are incredibly powerful general-purpose AIs. They're like a brilliant university graduate who knows a little bit about everything.
But what if you don't need a generalist? What if you need a specialist? Say an AI that's an expert in writing legal contracts, or one that can answer customer service questions in your company's specific tone of voice.
Exactly. To do that, you need to take the general AI and give it some extra training on a specific task. This process is called fine-tuning. It's like taking that brilliant graduate and putting them through an intensive training program to become a specialist, like a heart surgeon.
And just like training a heart surgeon, fine-tuning an LLM takes a lot of time, a lot of very expensive computing power, and a lot of data. You have to do this whole costly process for every single specialty you want.
The paper points out that even with more efficient methods, it can still take hours and multiple high-end GPUs to adopt just one model for one task. Now imagine you're a company with thousands of clients and each one wants a slightly different AI. Doing that one by one is a huge bottleneck.
This is where drag and drop LLMs come in. The researchers asked a really clever question. What if we could skip the entire training process altogether?
Their central idea is that the outcome of fine-tuning, the specialized brain of the AI, is really just a direct result of the data it was trained on. The specialized knowledge is a function of the training examples. So could you build a machine that learns that function directly?
So instead of teaching the AI with the data, you teach a different AI to look at the data and just predict what the perfectly trained AI would look like.
That's the magic trick. Here's how they did it. First, they did the hard work up front. They took a bunch of different tasks, math problems, coding challenges, common sense questions, and fine-tuned a model for each using a popular method called LoRa.
We can think of LoRa as a kind of surgical brain implant for the AI. Instead of retraining the whole brain, you just train a tiny, efficient add-on module. So now the researchers have a collection of these specialist modules, or LoRa weights.
And crucially, they have the data that created each module, so they have pairs. They have the math problems data paired with the math expert module, the coding questions data paired with the coding expert module.
Now, for the drag and drop part, they trained a new AI, which they call a parameter generator. Its only job is to learn the connection between those pairs. It learns to look at a few example prompts from a task and directly generate, or predict, the perfect LoRa module for it.
So when you want to specialize the AI for a new task, you don't need to do any training. You just drag in a few examples, say a few sample customer support chats, and the parameter generator instantly drops out a brand new custom-built customer support module for your LLM in seconds.
Okay, that sounds amazing, but does it actually work? Is the instant microwave version as good as the slow-cooked original?
According to the paper, it's not just as good, it's often better. First, speed. They report it's up to 12,000 times faster than the traditional approach. That's the difference between waiting for a package to arrive by sea and downloading it instantly.
12,000 times. That's incredible. But what about quality?
This is the wild part. On a whole range of new tasks that the system had never seen before, the drag and drop models performed up to 30% better than models that were fine-tuned the traditional way.
Wait, how can it be better? That doesn't seem intuitive.
The authors suggest that because their parameter generator is trained on so many different tasks, it doesn't just learn one specialty. It learns the general art of how to specialize. It learns the underlying relationship between a problem and the ideal brain structure to solve it, making it more robust and effective than a model that just crams for one test.
So it's like training a master mentor who can instantly turn any student into a specialist, rather than training each specialist from scratch.
A perfect analogy. They even tested this by training the generator on tasks like common sense and reasoning, and then asked it to create a module for a totally different domain, like science questions, and it still worked beautifully, outperforming the models specifically trained on science.
This really feels like a shift in thinking. The big takeaway is that the weights of an AI, the numbers that actually make it work, can be treated like a new kind of data. They don't have to be the end result of a long, slow process. They can be something you generate on the fly.
Exactly. The old way was data leads to training, which leads to model weights. This paper proposes a new way. A prompt leads directly to model weights. It's a shortcut that can make powerful, customized AI accessible to everyone.
The possibilities are pretty exciting. You could have an AI that learns your personal writing style from just a few emails, or a research assistant that adapts to a new scientific field in seconds.
It's a simple concept with profound implications. And it all comes down to a simple idea. Just drag and drop.
And that's our paper for today. Thanks for tuning in to Daily Papers.